so that the reaction between a enolizable carbonyl and a non-enolizable carbonyl. So what happens if we have two enolizable ketones? So for example, if we have a reaction between acetone and acetophenol, so what happened? As you can see that we have alpha hydrogen at both compounds. So we can form the enolate or enol with both acetone and acetophenol, right? So both compound can be enolized. So in this situation, and for example, if we use sodium hydroxide as a base for this reaction, so we're gonna form a mixture of products. So the first product is the self Aldol condensation of the acetone. Another product is the product between acetone with acetophenol. In this case, the acetone will be the enolizable carbonyl, and the acetophenol will be the electrophile. The next product we have is the self Aldol condensation of the acetophenol. So we have this product. Also, we have another product in which the acetophenol will be the enolizable carbonyl, and the acetone will be the electrophile. So as you can see, we have a mixture of products. So we have 4 products formed in the reaction between two enolizable ketones. So this is bad, right? This is not good because we form a mixture of products. So how can we eliminate this situation? So how can we just form just one product instead of a mixture of products? Well, there are 2 ways that we can use to eliminate this situation. So this situation here is the mixture of products. So the first way we can use is we choose a carbonyl compound which is much more active nucleophile. Alright, we choose one carbonyl compound and it is much more nucleophile. So usually we set up a reaction between just one enolizable carbonyl compound with a non-enolizable compound. So we just use one enolizable compound. The second way that we can use to eliminate the mixture of products is we choose the reaction and in which we have one carbonyl compound and it is much more electrophilic than the other one. Alright, so we choose one carbonyl compound which is much more electrophile. Usually we set up the reaction between an aldehyde and a ketone because aldehyde is much more electrophilic than the ketone. So aldehyde will be the electrophile and the ketone will be the enolizable carbonyl compound of the reaction. Stoichiometry is another important feature that we need to take into account when doing the Aldol condensation reaction. Take a look at the cyclohexanol. So in this compound, we have 2 alpha carbons and we have alpha hydrogens here on both sides. So we can form the enolate or enol on both sides, right? So both sides can be enolized. So for example, if we have the reaction between cyclohexanol and benzaldehyde, and imagine that we do the reaction between one equivalent of cyclohexanol and one equivalent of benzaldehyde. In the presence of sodium hydroxide, we form this product, and the reaction happen at one side of cyclohexanol. Another example is, so we have the same reaction between cyclohexanol and benzaldehyde. But now we use one equivalent of cyclohexanol and two equivalent of benzaldehyde. And again, in the presence of sodium hydroxide. So we're gonna form this product. We have the reaction happen in this side, on the right side, but also the reaction happen on the left side. So when we use two equivalent of the benzaldehyde, the reaction happen at both sides of cyclohexanol. All right. So different stoichiometry give rise in different product. So in today's experiment, we're gonna run the reaction between an aldehyde and 4-methoxy acetophenol. So we have 4 aldehydes. So you're gonna choose one of them and react with 4-methoxy acetophenol. So the first step you need to do is to make the solution of potassium hydroxide, and the concentration of the solution is 10%. So you're gonna use the solid potassium hydroxide, dissolve it in ethanol. So you need to calculate the amount of potassium hydroxide you need to use in order to make 10% solution of potassium hydroxide in ethanol. Next, you're gonna combine the aldehyde and the ketone. So you use 10 millimole aldehyde and 10 millimole ketone, and you put them in the 50 milliliter LMAO flask. All right, so you need to calculate the amount of both reactants. Then you're gonna add the alcoholic potassium hydroxide that you make in step 1. So you use 4 milliliter, you add that into the reaction flask, and you add a stir bar as well. Then you're gonna stir the reaction at room temperature for 20 minutes. Then you're gonna chill the reaction mixture in an ice bath. So make sure that we have some solid precipitate out of the solution. Then you're gonna collect the crude product by using vacuum filtration, and you're gonna use the ice cold ethanol to wash the solid. And then you're gonna purify the product using recrystallization, and we're gonna use ethanol as a solvent for recrystallization. And then after that, you're gonna use TLC, melting point, and proton NMR to characterize the product. And that's it for today's videos.